Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Up to last session, we have seen some of the applications of partial derivative such as the extreme values. In today's session, we are going to take Lagrange's method of undetermined coefficient for extreme values. Now, first of all, extreme values with a constraint. Sometimes we have to find the extreme value of more than two variable function or three variable function or more than three variable function, say f of x, y, z, subject to the constraint g of x, y, z is equal to 0. The extreme value of f of x, y, z in such a situation is called a constrained extreme value. Okay. In such a situation, g of x, y, z is equal to 0 is used to eliminate one of the variable. Suppose if you are going to put the value of z from this equation in original function, then you have a two variable function, and for two variable function you can use the simple method of extreme values. Same manner you can eliminate y also, you can eliminate x also. But instead of that, we are going to apply the Lagrange's method to find the extreme values with constraint variable. Okay. So if u is a function of x, y, and z, be any function given subject to the constraint g of x, y, z is equal to constant, where c is any constant, and we have to find out the extreme values of a function with respect to the condition. Then in that case we have to follow the following steps. First one, form the Lagrange equation. That means we are going to form one Lagrange equation. Capital F of x, y, z is defined as small f plus lambda into g minus c. That means you have to write down your function. You have to define a new function capital F is equal to function plus lambda into condition. Okay, where lambda is nothing but it is a Lagrange multiplier. Now, for extreme value or stationary point, we are going to take a partial derivative of f with respect to x, y, and z, and then we are going to equate them with 0. That means del capital F upon del x is equal to 0, del capital F upon del y is equal to 0, and del capital F upon del z is equal to 0. Now, in step 3, find out the values of x, y, z, and lambda from the above three equation, and using the condition g of x, y, z is equal to c. Because see, you have four variables x, y, z, and lambda, and if you have to solve them, then you need four equations. So above three equation and fourth one is our condition. So we have four equation to solve the four variable system. Now, whatever the values of x, y, z you have, at that find out the values of f of x, y, z, and that value is the extreme value of your given function with subject to the constraint. That means with respect to the given condition, that value is going to be a maximum or minimum. Okay. Now we are going on to the example. The temperature T is given by T is equal to 400 x, y, z square. Then find the maximum highest temperature on the surface of a unit sphere x square plus y square plus z square is equal to 1. Now here you have T is equal to 400 x, y, z square, and sphere is your condition. So we are going to write down sphere is equal to g is equal to x square plus y square plus z square minus 1. So first we are going to define the Lagrange equation. We are going to form the Lagrange equation. So capital F of x, y, z is equal to t of x, y, z plus lambda into g of x, y, z minus c. That means capital F of x, y, z is equal to 400 x, y, z square plus lambda into x square plus y square plus z square minus 1. Okay. Now, differentiate with respect to x, with respect to y, and with respect to z, and equate them with 0. So del f by del x is equal to 0. That will give you 400yz square plus lambda into 2x is equal to 0. And we are going to make lambda subject. That will give you lambda is equal to minus 200yz square divided by x. That is equation number 1. Same method, del f by del y is 0. That will give you 400x square plus lambda into 2y is equal to 0. And if we are going to find the value of lambda, and that will give lambda is equal to minus 200x square divided by y. That is condition 2. Same method, del f by del z is equal to 0. That will give you 800xyz plus lambda into 2z is equal to 0. So that will give you lambda is equal to minus 400xy. Now, we are going to solve 2 at a time. So, from equation 1 and 2, if we are going to solve them, then equate them, because left hand side is same, so right hand side is going to be same. So, you will have minus 200yz square upon x, that will is equal to minus 200 xz square upon y. Minus 200 cancel out from both sides, z square cancel out from both sides, and that will give you x square is equal to y square. Same manner, equate equation number 2 and 3. That will give minus 200xz square divided by y is equal to minus 400xy. So, minus 200 cancel out from both sides, and x will be cancel out from both sides. That will give z square is equal to 2y square. Now, we are going to use this relation in our condition. Our condition is what? X square plus y square plus z square is equal to 1. So, that will x square is equal to y square and z square is equal to 2y square. So, we are going to write down all the terms in the form of y. Then you will have y square plus 2y square is equal to 1. That will give you 4y square is equal to 1, and that will give you y is equal to plus or minus 1 by 2. If you are going to put this value in a x square is equal to y square, then you will have x is equal to plus or minus 1 by 2. And same manner, z will be a plus or minus 1 by root 2. Now, what we are going to do, you have a points x, y, z is equal to plus or minus 1 by 2, plus or minus 1 by 2, plus or minus 1 by root 2. So, basically we have 8 combination, and if you are going to find the values of t at each point, then you will get the maximum value 50 units and the minimum value minus 50 units. So, we have a 2 points, 2 conditions. Either maximum value will be 50 and minimum value will be minus 50. But here we require only highest temperature. So that will be a 50 on a sphere. Okay. Now we are going on to the another example. A rectangular box open at the top having the volume 32 cubic units. Okay. And find the dimension of such a box requiring the least material. That means you have to find the dimensions. That means you have to find out the length, breadth and the height for the box for which the minimum material is required to build such a box. So what we are going to do is, volume is given, correct? And we are going to suppose that dimension of the required box are x, y and z. But x, y and z are the dimension, that means length, breadth and height. Then by volume is 32 cubic unit, therefore x into y into z, that will be a 32. That same manner you have to extremize the surface area, because material you require is nothing but they are the 6 surfaces, but it is open at the top, so you have 5 sides and therefore you have to minimize the surface area. So S will be xy plus 2yz plus 2xz. Now, if we are going to form the Lagrange equation, and Lagrange equation is nothing but capital F is equal to S plus lambda into V minus C. So your F will be a xy plus 2yz plus 2xz plus lambda into xyz minus 32. So first differentiate with respect to x and equate it with 0. That will give you y plus 2z plus lambda into yz is equal to 0. So that will give you lambda is equal to minus of y plus 2z divided by yz. This is equation number 1. Same manner, del f by del y is equal to 0. That will give you x plus 2z plus lambda into xz is equal to 0. And if you are going to make lambda subject, then you will have lambda is equal to minus of x plus 2z divided by xz, and that is also equation number 2. Same manner, del f by del z is 0. That will give you 2x plus 2y plus lambda into xy is equal to 0. That means lambda is equal to minus of 2x plus 2y divided by xy. This is equation number 3. Again, use the same method. First, equate equation 1 and 2. That will give you minus of y plus 2z divided by yz is equal to minus of x plus 2z divided by xz. Cross multiply. That will give you xy plus 2xz is equal to xy plus 2yz. And that will give you 2xz is equal to 2yz. That will give you x is equal to y. Same manner, equation 2 and 3. From equation 2 and 3, we will have minus of x plus 2z divided by xz is equal to minus of 2y plus 2x divided by xy. So cross multiply and simplify. That will give you the result y is equal to 2z. So that will give you the result x is equal to y is equal to 2z. This is the relation between x, y and z. But our condition is what? X, y, z is equal to 32. So put the value of x and y and z in either of form. So here we are going to write that x is equal to 2z, y is equal to 2z and z is equal to z. Then that will give you 4z cube is equal to 32. That will give you z cube is equal to 8. So you will have z is equal to 2. Now what we are going to do is put that values in a relation that will give x is equal to 4 and y is equal to 4. Correct? So your dimensions are 4, 4 and 2. So dimension is nothing but if you are writing in the unit form, then x is equal to 4 unit, y is equal to 4 unit, z is equal to 2 units. Okay. Same manner, we are going to take another example. Find the shortest and the longest distance from the point 1, 2, minus 1 to the sphere x square plus y square plus z square is equal to 24. That means you have given one sphere x square plus y square plus z square is equal to 24. And one point is given which is outside of the sphere. Outside, that means either inside or outside. Okay, so this point is a 1, 2, minus 1. And now you have to find the extreme values from this point. That means from this point you have to find the minimum distance and the maximum distance on the sphere. So first you have to apply the distance formula. Because we are going to take one point on a sphere, let x, y, z be a required point on a sphere x square plus y square plus z square is equal to 24, and which is having a shortest or the longest distance from the point 1, 2, minus 1. Now what we are going to do is f is equal to d square. That means we are going to define function is equal to distance square. But distance is nothing but under root of x minus 1 square plus y minus 2 square plus z plus 1 whole square. Correct? So that will give you distance at f is equal to x minus 1 square plus y minus 2 square plus z plus 1 square. And g is your condition, that is a sphere x square plus y square plus z square minus 24. Now form the Lagrange equation. That will be nothing but capital F is equal to small f plus lambda into g minus c. That means it is nothing but x minus 1 square plus y minus 2 square plus z plus 1 square plus lambda into x square plus y square plus z square minus 24. Now for extreme values, del f by del x is equal to 0. That will give you 2 into x minus 1 plus lambda into 2x is equal to 0. So that will give you lambda is equal to 1 minus x upon x. Same manner, del f by del y is equal to 0. That will give you 2 into y minus 2 plus lambda into 2y is equal to 0. So you will have lambda is equal to 2 minus y upon y. That is equation 2. Same manner, del f by del z is equal to 0. That will give you 2 into z plus 1 plus lambda into 2z is equal to 0. So that will give lambda is equal to minus of 1 plus z upon z. That is equation number 3. Now equate 1 and 2. That will give you the relation 1 minus x upon x is equal to 2 minus y upon y. Cross multiply and simplify. That will give you x is equal to y by 2. Same manner, equate 2 and 3. That means 2 minus y upon y is equal to minus of 1 plus z upon z. And if you are going to simplify that, cross multiply and simplify, then you will have z is equal to minus y by 2. Now we have a relation x square plus y square plus z square is equal to 24. So put the relation, so x is equal to y by 2, z is equal to minus y by 2, put all values, that will give y square by 4 plus y square by 4, sorry, y square by 4 plus y square plus y square by 4, that is equal to 24. So simplifying this one, that will give y square is equal to 16. So you will have y is equal to plus or minus 4. So when y is 4, then x is 4 and z will be a 2. Sorry, y is 4, then x will be 2 and z will be minus 2. Same manner, y is minus 4, then x is minus 2 and z will be a plus 2. Because the relation you have is x and y are positive, then z is negative. So your points are x comma y comma z is equal to 2 comma 4 comma minus 2 and minus 2 comma minus 4 comma 2. So for both of them, we are going to find the distance. So first we are going to find the distance for minus 2, minus 4, 2. Then you will have distance value is under root of minus 2 minus 1 whole square plus minus 4 minus 2 whole square plus 2 plus 1 whole square. That is under root of 54. That is 3 root 6. Same manner, find the on second point 2 comma 4 comma minus 2, and thus that distance is root 6. So you have one distance is 3 root 6, second distance is root 6. So root 6 is the shortest distance and 3 root 6 is the longest distance. You have to write down this according to the value of your function. Okay, so we are going to find the value and then we are going to say which one is a maximum, which one is a minimum. Here the first one, 3 root 6 is a maximum and root 6 is a minimum. So that way that will give you your condition. Okay, so these are the topics of this session. If you have any query or any doubt regarding these topics, then please feel free to contact.